Lesson 68 is more about complex fractions. We learned about complex fractions back in Lesson 55, so if you've forgotten about those or you're still confused about them, you might want to review that lesson before you do this one. I think the best way to explain this lesson will just to do some practice problems. Now in Lesson 55 you learned that to simplify a complex fraction you inverted the denominator and multiplied above and below by that inverted denominator, and that's using what's called the numerator-denominator same quantity rule. You multiply above and below by the same quantity, you don't change the expression, you just change the way it looks. And when we simplify a complex fraction, we're trying to get it just into one fraction bar instead of 3 like there are in this example. Now the difference in this lesson and the previous lesson that you did on complex fractions is now you'll have to simplify within either the numerator or denominator or both before you simplify the entire complex fraction. So look at that problem there, 1 over a over 1 over a plus 1 over b. We need to simplify the denominator into just one fraction before we can simplify the whole thing. And so let's go ahead and do that as our first step. And so let's just rewrite 1 over a, and then think about what we would have to do there on the denominator. We'd have to get a common denominator by multiplying on the left by b over b, and then the other one by a over a. Okay, so now we can go ahead and write that answer, the denominator of the denominator fraction. If that sounds a little confusing, sorry about that, but that's what it is, right? It's the denominator of the denominator fraction, and it is ab, and then we'll have for our numerator 1 times b plus 1 times a. Okay, now we can go ahead and simplify the entire fraction, and it's always a good idea anytime you have a sum in the numerator or denominator of a fraction to put that in parentheses to remember that as one group. So next we invert and multiply above and below by the inverted denominator, ab over b plus a, ab over b plus a. Everything on the bottom cancels, and then on the top, you know, this is all multiplication, so this a and this a can cancel, and then we just end up with b over b plus a, and so that would be our answer, b over b plus a. Let's do another one. In that problem we see that we need to simplify the numerator part and the denominator part of the big fraction first. So we do that by doing the numerator first, and let's just look at that. We can make that a 3 over 1 to think of that as a fraction, and so we see that our common denominator there needs to be a b. So we need to multiply 3 over 1 by b over b. And so let's go ahead and change that. For the numerator fraction, our new denominator will be b, and then over 3b, or I'm sorry, 3b plus 1 will be the numerator. 3b plus 1 over b. Now let's look at the denominator fractions. X over b minus 5 over b. We have a common denominator there, so we don't need to multiply by anything. We just need to add the numerators together, x minus 5. Okay, now we can simplify the fraction. Put sums inside parentheses, and then let's go ahead and multiply above and below by the inverted denominator, so that would be b over x minus 5, b over x minus 5. The bottom cancels. On the top, the b's cancel out, and we end up with 3b plus 1 over x minus 5. So to simplify these complex fractions, first we look and see if we need to simplify within the numerator fraction and the denominator fraction. If we do that, we just get common denominators, add as we need to. Then once we get one fraction in the numerator, one fraction in the denominator, then we invert and multiply the denominator, cancel as we need to, and we end up with one fraction. a lot of problems I work the problems out vertically. These ones I've been working them horizontally or left to right. And that just helps keep up with what's in the numerator and what's in the denominator a little bit better. You can work them vertically if you want to. It's just whatever works better for you. That's just how I'm doing them. I think that's a good way to do it, is work them horizontally from left to right. That's one of the real important things in algebra, is you don't want to get disorganized in your problem solving. And so you want to try to include steps to help you eliminate problems like that and eliminate possible chances to make a mistake. For me, the more the second step looks like the first step, that helps me to keep things connected and understand how this part connects with that part. Let's go ahead and do one more problem. In this one, we have some negative exponents, and so what we need to do here is make those positive, and then we'll end up with a complex fraction when we do that. So let's just go ahead and change the numerator to c over x plus a over x squared, and then all of that will be over c over y. So now we have a numerator fraction and a denominator fraction. The numerator fraction, we can add those two together, but first we need to get common denominators, and so that means we need to multiply on the left by x over x, and we get x squared for our denominators. Now let's go ahead and rewrite this fraction. The numerator fraction, its denominator is x squared, and so that'll be over cx plus a. Cx plus a over x squared. We've got a sum there, so let's go ahead and put that in parentheses, and then all of this will be over c over y. Now we go back and we invert the denominator and multiply above and below by that, y over c times y over c. And so the y over c, that cancels, and then we have a cx, we have a c in that cx, and then a c in the denominator for that numerator fraction, but we can't cancel those because we don't have a common factor to factor out. So we just say parentheses, well actually I'll just say cxy plus ay over cx squared. I wrote that answer a little close to the previous step, so I moved it down there so you can see it. I just expanded that out, that what was in parentheses. I multiplied the y by the cx and then the y by the a to get cxy plus ay over cx squared. So that problem C was a little bit different than A and B in that we had negative exponents. So when you see a problem like that and they tell you to simplify it, that's always your first thought, is to change the exponents to positive exponents. Then on a problem like that, hopefully you will recognize that you have a complex fraction, and then you know that you need to simplify the numerator fraction and the denominator fraction. Simplify those first. Once you get those simplified, then invert the denominator fraction, multiply above and below by it, and that'll cancel it, and you just get one fraction for a result. Okay, well that's all for lesson 68.